if we wanted to have a different bin width, I highly recommend when you make a histogram of some variable you want to look at, to use a few different bin widths, because sometimes the data is strange, or there can be, if your bin width is too wide, you can hide a lot of data in there. So I'll just demonstrate that. If I make the bin width 2000 in this case, remember I said if we wanted to make only 3 bins for this data, the bin width would have to be about 2000, right? You can see that. So if we run that, that's what the data looks like. So that's not very informative at all. Like, to look at this plot really doesn't teach us a lot about our data. If you compare it with this plot, this is already much better to be able to see where most of our values lie, because that's the point of a histogram. That's the reason we make a histogram, is we want to understand where are most of the values, where are very few values. So we see here these low values. There are very few individuals who had this value, very few individuals who had these higher values, and the bulk of individuals have these values. So over here we can see, what that looks like. Whereas if we had a bin width that was too wide, this isn't informative. It just tells us there are few people here, but there's lots of people here, across a wide range. So where are they? Like, are they all, are they evenly spread here, or everyone actually at 2,500? And so this is not informative. So let's put it back to a more narrow bin width. So then, if our bin width is more narrow, you're expecting more bars, right? If your bin width is wider, you're expecting fewer bars. So let's run that and see what we get. So now you can see this is even more informative. This is a much nicer graph already, because now we can see, look at all much more information over here. We can see there's actually a dip here that we wouldn't have known is there if we were just looking at these previous graphs, or even this one. Over here it just looked like everyone, basically, that there's an equal number of individuals in each of these bins. But having a narrower bin width with more bars, we can actually see, oh no, there's fewer individuals in this bin and in this bin. The most individuals are actually over here and over here. So this is already a much more informative graph. So you should play around with your own data and find the bin width that gives the most information. So it will be different for different variables, as you can imagine. This 100 or 500, that depends on what is on your x-axis, right? So this is a continuous variable, and it ranges from 0 to about 6,000. But if you imagine, if we had plotted weight in this case, it wouldn't have gone from 0 to 6,000. It would have gone from, probably, if it's adults, let's say something in the 30s to maybe 120 or something. And in that case, if you said bin width 100, that wouldn't make sense at all, right? That would create only 2 bins for you, or only 1 bin actually, if it started from, about 30 to 120. So that wouldn't make sense at all. So in that case, you would probably make your bin width something like 10, because that will be much more informative for this specific variable that you're looking at. Okay, so you should experiment with that, and that's what you're going to do now. Here's some instructions for you. It says now you must draw a histogram of IP10 stim. So IP10 stim is a variable. It's another variable in your data set in your my sample, like CRP null, IP10 stem is another variable. It says you must add 2 vertical lines. So remember, we added vertical lines with geomv line. Let me just minimize this, show you over there. And as you had to specify the x-intercept over here, you have to also specify it. So one of the vertical lines must be for the mean. I want you to draw a vertical line at the mean of this IP10 stem, and draw a vertical line at the median of this same IP10 stem. So you have to replace this 3000 and 3500 with the mean of your of this IP10 stem variable, and with the median. And I'm telling you, make the line red. The line for the mean must be red, and the line for the median must be orange. And so you must replace that in that code. And remember, you must make a histogram. So basically, you look back at this code and you try to make your own histogram, adding geomv lines as specified here. So what I will do is I will just give you a clue about this mean and median. So you've seen these functions before, I think, when we were looking at data and learning about functions. So that shouldn't be too difficult. If you want to calculate the mean, you're going to use that function. If you want to calculate the median, you're going to use that function. Inside the brackets, you're going to have arguments. As before, you have to tell R what do you want the mean of, because R wouldn't know which mean you're trying to calculate. So you are going to use your data set called my sample, and obviously it wouldn't make sense to say you want the mean of a whole data set. That doesn't make any sense. So it's a specific column you want the mean of, and as soon as you want to tell R about a specific column, you use a $sign. Now you even get some suggestions. So if you start typing I, you're going to get the suggestion, you find the one, IP10 stem, that's the one you're looking for, tab. And so that's how you're going to tell R which mean you want. So you can either do it like this. If you run that code, you find your mean here, 2,900 whatever in my case. So you can either do it like that, and so like I said, you're going to use the mean. You're going to replace this 3000 with whatever the mean is, right? So you're going to put this thing in place of that 3000. So you can do it like that, or what is probably a better principle is to just use any placeholder. So just use the letter A, and then work out the mean, but save it as an object just called A, or whatever you want to call it. Don't call it mean, because mean is already a function. So that's going to be confusing if you call it the same thing that already exists. So just use something simple like A, for example. Put that there. This arrow, so you would normally create it with on my keyboard it's the comma. The key where the comma is also has this strange bracket, not sure what you call it, and a dash. So that's how you create this thing. There's a shortcut for this assignment function. Press Alt and the dash. So Alt and the dash will create that for you automatically. So if you're going to do it like this, then you're calculating the mean of the variable you care about. You're saving the answer in an object called A. So if you run that, as you can see, nothing really happens. You just see that you ran it. If you want to see what the answer was, you have to type A, run that line of code, and then it's going to show you, and you'll see it's the same as what we got before. If you want to do it this way, then you are going to put A, which is a placeholder for this number, in the place of the 3000. So you're not going to replace 3000 with this value. You're not going to type in 2903. You're going to type in A. And then R knows, oh, A is just a placeholder for this value. So that's what you have to do now. Try to make this plot.